So hello dear students, welcome to the lecture 2 of the course, and from this particular lecture we will be dealing with some rules related to logarithms, and based on that rules we will be solving numericals. Okay, so let's start the lecture. Okay, so let's suppose you have one equation. Let's suppose the equation is a raised to x is equals to m. Okay, and obviously we all know that this particular equation is exponential in nature. Why? Because here the power is x and it is like a raised to x. Okay, and how can we write this particular equation in logarithmic form? Remember one thing, in future or in mathematics or maybe in any other subject, because this particular thing you would be rigorously using in physics, chemistry, or maybe in different subjects. So whenever you get exponential term, you try to convert it into log so that your further calculation would be absolutely easy. Okay, so this particular equation can be written as in this way. See, x is equals to log m to the base a. Okay, we'll see this particular thing what exactly it means. So let me write the thing, let me write over here. This a is nothing but a is base of log. Okay, x is an exponent, x is an exponent, and m is any random number or constant, which we will be seeing or which we will be dealing in the numericals. We will see exactly what it is. So let me highlight it with the help of box. Okay, so this is one equation and this is another equation. So this particular equation, it is known as exponential equation. Okay na? And this particular equation, it is known as logarithmic equation. We did not worry, we will see this particular thing what exactly it is, but remember one thing, this equation is equals to this equation. Just the thing is that we are dealing with log over here. Okay, just remember this particular thing. Now we'll move to the next page and let's take one example to understand this particular thing. Let's suppose we have, but before that what I will do is I will take this two particular equation to that next page, so that it would be easy for us to solve that particular numerical. Control V, somewhat like this. Oh, I think it didn't came properly. Just a second. Oh, sorry, extremely sorry once again. Just a second, I will take this particular thing to the next page. Yes, Control C, Control V. Yes, so as you can see we have these two particular equation, and now based on this particular equation we are going to solve one numerical. Okay, so let's suppose you have given one equation, that is, we all know 2 raised to 3 is equals to 8. Okay, cube of 2 is 8. So how can we write this particular thing in logarithmic? See, this is an exponential form. It is an exponential form. So basically we have to convert it into logarithmic. So as you can see above, over here, see this 3, here the x is 3, here the x is equals to 3. Okay, m is equals to 8. Yes, and what, and we have another term, that is a, and here a is equals to 2. So as you can see over here, we can, based on this particular equation, we can write this equation as what, 3 is equals to log 8 to the base 2. Okay, sir, I understood how to write this particular equation, but what exactly this particular equation tries to tell you? See, this is what it tries to tell you. By what power you have to raise 2, that means what power you have to raise 2 such that you end up getting the value as 8. What, sir? Can you repeat it again? Yes, why not? By what power you have to raise 2 such that you end up getting value as 8. Okay, by what power you have to raise 2. Okay, by what power you have to raise 2 such that you end up getting value as 8. And as you all know, 2 raised to x is equals to 2 raised to 3. Therefore you end up getting value of x is equals to 3, and this is what this particular equation tries to implies. See, it's one and the same, just the thing is that it was in exponential and this is in logarithmic form. Okay, this is in logarithmic form. I'm writing in short. It's one and the same. Okay, so now if you had understood this particular part, let me again move to this page and let me just uh, copy this particular formula once again. Okay, and then we will solve the very next numerical. Control C, yes, Control V, and I will move this particular equation little above so that we will have enough space to solve this numerical. Okay, so now let's suppose I'm taking the same base, that is 2. Alright, but I will take different color. Just a second. Yeah, 2 raised to 6 and the value is 64. Let's suppose this is your question. So how we are going to convert it in log? First of all, what we'll do, we'll see our base, our a is 2. Okay, then we have m as 64. Oh sorry, we have m as 64, and then we have x as 6. Good. So now it is absolutely easy for us to write it in logarithmic form. It would be 6 is equals to log to the base 2, and that is 64. What does that means? That means by what power you have to raise this 2, by what power, that means x, by that means 6, by what power you have to raise this 2 such that you end up getting the value as 64. Okay, again I'm telling to you, by what power you have to raise this 2, okay, such that you end up getting the value as 64, and thus we all know 2 raised to 6 is 64, and therefore x is equals to 6. And this is what this particular equation, this both of the equation tries to imply. Okay, the meaning of both the equation is same, just the thing is that here it is an exponential equation and this particular equation it is an logarithmic equation. Okay, so I hope you understood this particular thing. And one last numerical we are going to do. Again, what I will do is I will copy this particular equation, and yeah, I will just I'll just move this particular equation so that we have enough space to solve. So we will deal with very last, we are going to deal with very last numerical, but yes, after ending this video I will also give you one MCQ. I will embed one numerical in MCQ, so please try to attend that particular MCQ, okay, which will help you to clear the concept. So yes, let's suppose if I'm giving you, now we will take little difficult, let me take a different color. Okay, so let's suppose we have one equation as 25 raised to half, and that is equals to what? That is equals to 5. Oh, now you would scratch your head that such a huge number it is, and it is looking little tedious. But my dear students, it is not tedious. What you have to do, you have to just equate equate this particular x, a and m value. So here the value of x is half, okay na, value of a is 25, and value of m is 5. Oh, extremely sorry, value of a is 25 and then value of m is 5. So this is what we are seeing over here. So what we can do is this: half is equals to log 5 to the base 25. Just a second, I will write, it is looking very complicated, or in compile form. Yes, to the base 25. So what does that mean? This means that by what power we have to raise this 25 Okay, by what power we have to raise this 25 such that we end up getting the value as 5. Okay, we'll see again. Let me use some vibrant color. Yes, by what power we have to raise 25 such that we end up getting the value as 5, and we all know root of 25 is equals to 5. Okay, that means what? That means this 25 root 25 can be written as 25 raised to half, and thus we are getting the value of x is equals to half. So this is what it means. Okay, and as I told you, this is the I'm writing in shorter form, so please to try to understand. This is the exponential form and this is the logarithmic form. Okay, this is the exponential form and this is the logarithmic form. So I really hope that you understood this particular video. Again, we will revise the thing. So first, what we saw, if let's suppose if you have an exponential equation, so you should always think, or you should always keep in mind that okay, sir has told to us that whenever we are dealing with exponential equation, whether it may be in physics, chemistry, or mathematics, in any of the subject, so we have to convert, first of all we have to convert it into logarithmic form. So this is the logarithmic equation and this a is the base, and this a is the base and x is the exponent. Okay, so we understood this, and based on this what we did, we solved one numerical. The very first numerical was this. What I will do, I will just give the number to this particular numerical. So this was the very first numerical which we deal, or which we studied. And as we saw over here, see, we all know that cube of 2 cube is 8, but this was an exponential. How we will write this in logarithmic form? So log to the base 2, so this 2 came over here in the base of log, and this is 8 and this is the 3, and this particular thing implies that by what factor we have to raise 2 such that we end up getting 8. So this is what it means. We have to raise 2 with 3 so that we end up getting 8, and this is the logarithmic equation. Okay, then moving further, we saw the very second numerical. Rather than instead of 3 we just took 6. Okay, and again we had converted this particular equation. This was the exponential form, this was your logarithmic form. The 6 came over here to gone to the base of the logarithmic log. Okay, that means log to the base 2 is 64. That means by what power you have to raise this 2 such that you end up getting 64, and that we saw over here. We have to raise this particular 2 by power 6, by factor 6, and thus we are successful in getting this particular number. And the last numerical, by what power we have to raise this particular 25 such that we end up getting end up getting answer as 5. Okay, that means 25 raised to half is equals to 5, so we converted it into log. Half is equals to log to the base 25, and this is 5. Okay, and this is what we saw over here. So although I'm ending this video over here, but remember one thing, or just keep in mind that yes, I will be also embedding one MCQ in the Udemy section. So it's my request, please do solve that particular MCQ, which will give you a clear-cut insight of this particular conversion from exponential to logarithmic equation. Okay, so thank you for listening patiently. I'm ending this video over here. Thank you.